All right, chapter 11, section 7. We did surface area of cylinders for 11.5. I'll just briefly go over it, but then we have surface area and volume of cones. So that's new. So we completed this slide for 11.5. Okay, we covered this already, but just going over it again, you have a cylinder. Okay, so drawing it as best as I can. Here's my cylinder. Your lateral area of the cylinder. The lateral area is that side. It kind of looks something like a rectangle. So your lateral area is, excuse me, you have 2 pi r stands for the circumference of a circle. That's what this side measures. Then you have your height. So looking at my height, this would be considered my height, and that's for the lateral area of my cylinder. Okay, so when I'm looking at it, this is 2 pi r. This is my height. I'm just multiplying it to get that lateral area. Total surface area of a cylinder. I'm going to take that lateral area. I'm going to take the formula of that lateral area, so that's this entire thing, which is my side, and I'm multiplying it times 2 of my bases. So if I'm looking at it, here's base 1. Let me get a darker color. Nope, that one's not working. Here's base 1. Here's base 2, and I'm taking the area of the circle, okay, because it's asking for the area, so I have to take the area of the circle. Okay, so please make sure you understand that. Again, we did this in 11.5. So if you look at the formula, this is volume is given to you, not area, so please be aware of that. Okay, area is gonna, you have to know the formula for area, so just be aware of that. You have to know how to find surface area of a cylinder, which is this entire thing right here. All right, let's go ahead and get into cones. Please pay attention to your cones. There's a lot of information for cones dealing with not only your height, but also the height of the slant, okay? So if I'm looking at this diagram, we should all know what the vertex is. Okay, your vertex is this point right here at the top. Your height is that perpendicular line. Your lateral face is this entire thing. And your base for a cone, if you don't already know it, is a circle. Okay, slant height. You're only using slant height when you're trying to find your surface area. Slant height is represented as an L, okay, either a fancy L or an L. I don't want you to think it's an I. And you're only using this for surface area, or also known as total area. Okay, that's the only time I'm using my slant height. When am I using my height, my perpendicular height, is when I'm solving for volume. So please don't get those two mixed up because they are two different heights, using it for two different times. Yes? So either slant height's going to be given to you, or you can solve. So that's a good question. How would I find my slant height? If I have my height and my radius, how would I find this? Which is a question that we're going to get to on the next slide. So let me go ahead, or the next 2 slides. But looking at it, again, we should know, this is a right angle, and we should know how to find a missing side of my right angle. Do we see it? So if they're giving me my height, if they're giving me my radius, I can solve for my slant height using what? Pythagorean theorem. Okay, so that's a way that I can use to solve. All right, lateral face of a cone consists of all segments that connect the vertex with a point on the base edge. So it's just the side. So looking at the next slide, this is right here a net image of a cone. All right, so like I said, this is a net image of my cone as if it was flat. Okay, I opened it up and I laid it flat on a table or something. That's my net image. So lateral area of the cone, pay attention to this, is pi times my radius times my L. Remember what L stands for? L is going to stand for my slant height. Okay, so lateral area of my cone is just this right here. I'm going to highlight it. It's just this measurement. Okay, so I'm taking pi times r times my slant height. So if they're asking me for the total surface area, I have to first find the base, the area of my base, which is my circle here. And then I'm adding the lateral area. So another way to think about this is you have your capital B plus your lateral area, LA. Okay, that's a way to think about finding surface area. Keep in mind that's not volume. I did not use my height. I used my slant height. And again, it tells you L stands for slant height. Please do not forget this, because if you ever do need an L or you're solving for L, it has to be that slant height. All right, looking at volume of a cone, pay attention to this. The volume of a cone is, this is the formula that's given on your formula sheet. Okay, this is the formula that's given on your formula sheet, where we know the area of the base is pi r squared. So just writing what B is. If you're looking on the formula sheet, just be aware nothing's represented as B. They're giving you all the areas. So this is your area of the base. And again, that's pi r squared here. Okay, another way you can write this formula is pi r squared times height divided by 3. That's fine as well. So depending on what you want to write, that's up to you. Again, B is the area of the base, H is your height, R is your radius. So looking at the diagram, they're giving you all that information. If I'm finding volume, that's when I'm using the height at a 90-degree angle, not the slant height. So please do not get that mixed up with slant height. All right, going ahead and solving, it says they want us to find B stands for area of the base. Then they want me to find my lateral area. They want me to find my surface area and my volume. So looking at this diagram, do I have enough information to find everything? No. My volume needs my height. Do I have my height? No. How do I find my height? Pythagorean theorem. Good. Okay. So solving for my height before I go ahead and start solving anything else, I'm going to use my Pythagorean theorem and solve for the height. So solving for my height, my Pythagorean theorem is a squared plus b squared equals c squared. I'm going to have 5 squared plus, I'll represent it as x squared, that's my height, equals 8 squared. 25 plus x squared equals 64. Subtract 25 from both sides. And x squared is going to end up with 39. Getting rid of my squared, my height is going to equal the square root of 39. I'm just going to leave it like that. All right, so what else do I have? I have my radius. And I have my slant height, which we represent as L. Okay, my height, we solve for square root of 39. Okay, so again, slant height is represented as L. So I'm going to leave it that way. So looking at it, first they want me to solve for B. B, don't forget what B equals. B is considered the area of my base. Area of base. And what shape do I have as my base? A circle. So I have to know formula for area of a circle. Who could tell me what is the formula for area of a circle? What is the formula for area of a circle? Pi what? Pi r squared. So base equals pi r squared, and plugging in what I have. Pi, my radius they gave me, which was 5, and I'm squaring it. Was it 5? Yes, it was 5. So solving that, I'm going to have 25 pi. And then let's go ahead and round to the nearest tenth. Plugging that into your calculator, 25 times pi, I'm going to get 78.5 meters squared. All right, looking at the next one, let's go ahead and find lateral area. Remember, there is a formula for this one. Lateral area is similar to my area of my base, but I'm going to use my slant height, okay, for my lateral area because it's the sides of my cone. Side, it's one side, it's a curved side. So this is going to be pi r times my slant height. So pi, we know our radius is 5. Going ahead and finding what my slant height was, they gave it to me, it is 8. So 5 times pi times 8. Plugging that in, 5 times 8 is going to give me 40. So right now I have 40 pi. Plugging that into my calculator to give me a decimal, and rounding, I'm going to end up with 125.7 meters squared. Again, it's still area, so my units are going to still be squared. Next thing, they're asking me for surface area. Trying to find surface area, I have to find the area of both my base and my lateral area. So I have to go ahead and add both of these. Formula for this is my area of my base plus my lateral area. So it's going to be pi r squared plus pi r times L. I'm going to leave it in terms of pi until the very end. So because I solved the two previous ones, I'm going to have 25 pi plus 40 pi. Again, I'm rounding at the very end. This is going to end up giving me 65 pi. And then I can go ahead and plug that into my calculator. That's going to be rounded to 204.2 meters squared. Again, we're still dealing with area, so my units are still squared. Okay, please pay attention to that one. I did not solve everything out. I used the information in terms of pi for my previous questions. And looking at the last question that they gave us, they want us to find volume. Formula for volume, I'm going to have base times height divided by 3, or pi r squared times height divided by 3. And plugging in what I have. I have my pi. My radius they gave me was 5. Squaring it times my height. Let's see what my height was. I think we solved for height, which is the square root of 39. And all of that is going to be divided by 3. Yes, you can just plug the top part, plug it all into the calculator, but please don't forget to use parentheses. So I'm going to plug in 25 times pi times the square root of 39. Keep that in parentheses because I'm going to do that first. Then I'm dividing everything by 3. If you plugged it into the calculator correctly, your volume is going to equal 163.5 meters cubed. I'm cubing it because volume is in cubic units. So using the information that we have from our cone. All right, looking at example number 3. Again, I have to first find information on this diagram. What do I need? I need my radius and I need my height. They're already giving me my slant height. So if I'm looking at this, my slant height is 13. That's my L. Who can tell me what is my radius? 12 is half of 24, so that my radius is going to equal 12. Now how do I solve for my height? Good. Same thing I did before, Pythagorean theorem, because this is a right angle. So solving using Pythagorean theorem. I'm going to go ahead and solve it over here. I'm going to have 12 squared plus I don't know squared equals 13 squared. I'm going to get 144 plus x squared equals 169. Subtract 144 from both sides to get x by itself. X squared equals 25. Square rooting, and this is a perfect root, so x is going to equal 5. So my height for this diagram is 5 meters. Now I can go ahead and start solving for the 4 things they're asking me for. The first one they're asking me for is my base area. I'm just going to go ahead and write down what I had so I'm not going back and forth. My radius was 12. My slant height was 13. And then my height was 5. All right, so formula for my base area is pi r squared because it's a circle. That's the formula for area of a circle, and I'm plugging it in. I'm going to take pi times my radius, which is 12, squaring. I'm going to end up with 144 pi, and then changing that to a decimal. Rounding, I'm going to get 452.4 meters squared. Area is always squared. All right, looking at the next one, they're asking me for my lateral area. So my lateral area is pi r times my slant height. So pi times my radius times my slant height, which is 13. Multiplying 13 and 12, I'm going to get 156 pi. And then changing that to a decimal, I'm going to get 490.1 meters squared. Okay, again, you guys do have calculators, so please make sure you're rounding at the end. You don't need it until the very end. Surface area or total area. I'm going to be adding both of these. My formula is my area of my base plus my lateral area, which is pi r squared plus pi r times my slant height. And I'm just going to take my pi's. 144 pi plus 156 pi, add those together. I'm going to end up with 300 pi. And then changing that to a decimal, I'm going to get 942.5 meters squared. Okay, question on that one. Do you have any questions on how I'm finding my surface area? Okay, keep in mind I'm just taking it in terms of pi. So that's a good way when you guys are solving. Leave it in terms of pi until the very end, because your decimals can get messed up depending on what you're doing. And then looking at the last one, volume. I have to know the formula for volume. It's the area of my base times my height divided by 3, which is the same thing as saying pi r squared times height divided by 3, or multiplied by a third. You could put either one. So I'm going to have pi times my radius, which is 12, squared. Then I'm going to multiply it times my height. Remember, volume is the only one you're using your height. Surface area, you're using your slant height. And that's all divided by 3. Yes, you can just plug this into the calculator, but I'm going to end up getting 144 times 5 times pi over 3. 144 times 5 is 720 pi over 3. I could go ahead and simplify that to 240 pi. And rounding that, plugging it into my calculator, we'll just say it's 754.0 meters cubed. Volume is cubed. Any questions on these four? Okay. All right, we've done these for the past few lessons. Find the volume of a similar solid. So first thing I have to do is find my scale factor, which is represented as K. So I'm going to take 9 over 3. That simplifies to 3 over 1, which is just 3 as a whole. Now I have to cube my scale factor. So that's K cubed equals 3 cubed. That's 3 times 3 times 3, which is going to give me 27. I'm going to go ahead and write a ratio. I'm going to represent this volume as X. My ratio is going to be X over 15 pi equals 27. If you want to put it as 27 over 1 so you could cross multiply, that's fine. Cross multiplying, I'm going to get X equals 27 times 15 pi. 15 times 27 is going to end up giving me 405 pi. And then changing that to a decimal, my volume is going to equal 1272.3 feet cubed. Okay, most important thing for this one, do not forget to cube your scale factor. If you do not cube your scale factor, unfortunately, it will be incorrect. All right, last example, it says find the volume of the composite solid. Keep in mind, this is made up of two shapes. What are my two shapes? In order for me to get the total volume, oops, I forgot my M, of a composite is going to equal, what two shapes do I have? A cone and a cylinder. So I'm going to do volume of my cylinder plus volume of my cone. That's how I'm finding the total. So looking at it, let's go ahead. Volume of my cylinder. This is my cylinder right here. What's the formula for volume of a cylinder? All right, the formula sheet again is going to be given to you. So looking at it, here's my cylinder. Here's the formula for volume of a cylinder. It's pi r squared times your height. So no, you are not expected to know it, but we should kind of have an understanding of it. So looking at it, volume equals pi r squared times my height. And pi times, what's my radius for my cylinder? 3 squared. And what's my height of my cylinder? Good, 10. 3 squared is going to give me 9. 9 times 10 is 90 pi. Okay, so that's one part. Finding the next one, going ahead and finding volume of my cone. Are they giving me volume of my cone? Yes, they are. It's right here. Pi r squared times height divided by 3 or multiplied by a third. So going ahead, writing it down. I'm going to have pi volume equals pi r squared times my height divided by 3. So if you're looking at them, they're very similar. One's just being divided by 3 and one is not. So plugging in what I have, pi, what's my radius? It's going to be the same thing. My radius is still 3 squared. And what's the height of my cone? Again, we're only looking at the cone. What's the height of the cone? It's not 10. What is it? It's 5. Okay, please don't get that confused. The formulas look very similar, but I'm using the cone only, and then I'm dividing it by 3. So solving it, 3 squared is going to give me 9. 9 times 5, I'm going to end up getting 45 pi over 3. And then I can go ahead and simplify that to 15 pi. Keep in mind it's asking me for the total volume of my composite figure. So in order for me to find the total, I'm going to take both of them. Volume equals 90 pi plus 15 pi. I am going to round in the end, but it's just easier for me to solve it this way. If I add these two together, I'm going to get 105 pi. And then you can just plug that into your calculator. Your volume is going to equal approximately 329.87 centimeters cubed. I rounded that one a little bit more. All right, questions on this one? Okay.